Greetings, we have made it to the last cluster of standards. We have gone from kindergarten through 5th grade. As a reminder, in 278, if you need to take 278, we will cover the standards in grades 6 through 8, continuing to use manipulatives any way that we can. A good question to ask yourself or even think about is, when do we stop using manipulatives? And there's a ton of research out there on when one should stop incorporating manipulatives. But I think that as you get to know your students, students will just naturally just put the manipulatives away and start using algorithms. Some may take longer than others. There's just no real true set time. I still use manipulatives in my classroom, so um, if students need them, there's no reason why they can't use them. So our standards we're covering, our clusters we're covering this week are measurement and data and geometry. So here's a list of those that we need to cover with measurement and data. What is 24.65 multiplied by 10 and then by 100? In general, what impact does multiplying by 100 and by 10 and by 100 have on place value? From our place value chart, when we did numbers and operations in base 10, we know that multiplying by 10 means that 24.65 will be 10 times greater. So 24.65 becomes 246 and 5/10. We also know that multiplying by 100 means that 24 and 65/100 will be 100 times greater. So 24 and 65/100 times 100 is 2,465. Helen says all of the necklace cords are the same length. Gwen says that centimeters and millimeters are different from meters. So all of the lengths will be different. Who do you agree with? We have a color cord and then their lengths. 4 6/10 meters, 46 millimeters, and 460 centimeters. So I have our hundreds, or our regular place value chart, and then below it I have a meters chart. And so notice that they're color coordinated and the exact same operations will be happening. A digit to the left is 10 times greater than the one to the right. This is true about a metric chart as well. So using our place value chart for meters, I can list that 4.6 meters, or 4 and 6/10 of a meter, would land right here on the chart, and 46 millimeters would land with the 6 in the millimeter category because that is the last name for it, and then 460 centimeters, the 0 ends at the centimeter category because that is where we land. That's where the last place value is. Oops. I see that 4 and 6/10 of a meter is greater than 46 millimeters. I also know that 4 and 6/10 meters is equal to 4,600 millimeters because meters are larger than millimeters. And centimeters and millimeters are different from meters, so their lengths will be different. Even though the black and the silver are the same, the black and the gold are different. Measurement of length can be expressed with different unit sizes because we can convert from larger to smaller units by using multiplication. When we convert between measurement units, the length of the item remains the same. So Helen and Gwen bought a 4th package of cord. This cord is orange and is 46 decameters of cord in it. Does the orange package have the same amount of cord as the black package? How do you know? So here is our chart again. Here I have 4.6 meters, and I also have 46 decimeters. Therefore, 4.6 meters is 10 times greater than 46 decimeters, but 4 and 6/10 meters is equivalent to 46 decimeters because if we look at the place value chart, they're in the exact same location, just named differently. Mickey and Minnie ran in a 3.5 kilometer relay race. During the race, they each had to run at least 2 times, but neither could run more than 4 times. Determine one possible running plan for Mickey and Minnie. Be sure to indicate the total distance each mouse ran and support your answer with visual models. We know the following, that it is a 3.5 kilometer relay race. They have to go the same distance. They have to run at least 2 times and not more than 4. So if they ran the whole time, we know that they have to split and be the same distance. So 3 5/10 divided by 2 is 1 75/100. Mickey could have ran 1 plus a half a kilometer plus a quarter of a kilometer, and Minnie could have ran 75 thousandths of a kilometer plus 5/10 of a kilometer plus another 5/10 of a kilometer. Or Mickey could have ran 1 kilometer plus 25 hundredths of a kilometer plus 25 hundredths of a kilometer plus 25 hundredths of a kilometer, still being within the at least 2 times but not more than 4 times. And Minnie could have ran 75 hundredths of a kilometer plus 25 hundredths of a kilometer plus half a kilometer plus a quarter of a kilometer. And this one needs to change too. So these are just 2 different possibilities. There are quite a bit you could have chosen to make this work. Mickey and Minnie ran in a 5K fun run. As Minnie ran, she started thinking about the fact that her stride equaled 1 meter. At the end of the race, Minnie told Mickey that her stride was the same as 1,000 kilometers. Mickey said that she had it backwards, that her stride was the same as 1/1000th of a kilometer. Who do you agree with and why? So as we move left on our chart, we divide by 10. So 1 divided by 1,000 is 1,000th. 1 meter is equivalent to 1/1000th, oops, I have too many zeros, I apologize, of a kilometer. So therefore, Mickey is correct. So we went from a meter 10 times, 100 times, 1,000 times, divided by. Mickey and Minnie are at it again. Mickey says that 1 centimeter is equivalent to 1/10 of a meter. Minnie says that 1 centimeter is equivalent to 1/100th of a meter. Who is correct? Well, 1 meter is 100 times greater than a centimeter. So 1 centimeter is equivalent to 100th of a meter. The ship sailed 5 kilometers. How far is that in meters? So we're going from kilometers to meters, which means that we are going to multiply by moving right 10, 100, 1,000. 5 times 1,000 is 5,000 meters because kilometers are 1,000 times larger than a meter. Drake rode the unicycle 52 thousandths of a kilometer. How far was that in meters? So again, we're going from kilometers to meters, so we need to multiply by 1,000. So 52 thousandths times 1,000 is 52 meters. The height of the tube of tennis balls is 254 millimeters. What is the height in meters? This time we are going from millimeters to meters. So we will need to divide because meters are larger than millimeters, or millimeters are 1,000 times smaller than meters. So 254 millimeters divided by 1,000 is 254 thousandths of a meter. Some friends canoed 37.9 meters down a river. This was how many hectometers? So we're going from meters to hectometers. Hectometers are much larger than meters, so we will need to divide by 10 by 100 in order to get 379 thousandths hectometers. Minnie is making necklaces to sell. She wants to buy more cord to make more necklaces. She has visited 5 different stores to compare prices. She has made a table that shows the length and price of cord at different stores. Let's help Minnie choose the best option. So above at the top of the screen, I have our meter chart, and I have some different items. When I look at the cord lengths, some are in centimeters, some in meters, and some in millimeters. I think it would be best if we converted all of them into centimeters to really get a look for things. So when I look, we're going to start at store C. 7/10 of a meter times 100 would give me 70 centimeters. So I'm filling in what the centimeter portion is. Store A is already in centimeters, so we'll just carry that down. Looking at store D, 1,400 millimeters is how many centimeters? So going from millimeters to the left, one box, we need to divide by 10, so it would be 140 centimeters. Store B is already in centimeters, so I carried that down. Finally, store E is 1.4 meters. We are moving to the right 10, 100. So multiplied by 100 is 140 centimeters. When I compare looking at all the centimeters, when I look at the 70 centimeters, the best cost is store C. When I look at 140 centimeters, the best cost is store B. So it's kind of between the two of these. What I can do is double the centimeter, 70 centimeters, double that and double the cost so that we get to 140. So $6.99 times 2 is $13.98. When I compare $13.98 to $13.95, I see that $13.95 is the better deal at store B. Homework. Use pictures, words, and diagrams to determine what date and time it was 217 minutes after the beginning of January 1st, 2017. Scan and upload your thoughts to the What Time discussion board. Take a moment to review your classmates' responses and respond to one classmate's strategy. Mrs. Boyd measures and lists the widths in inches of books that will be placed on the travel shelf. Help her organize the data by completing the line plot. 1/4 is already placed for us on the line. Then I need to place a dot at 3/4, one at a half, another at 3/4, and now to get 1/8, I also see that my whole unit line is also divided into eighths as well. So I can place one at 1/8, I can place one at 1/2, I can count 5 copies of 1/8 to get to 5/8, another 3/4, and a 1/2.